Hi, so today we're going to be talking about sets and subsets. So first we have to define what is a set. And a set is a well-defined collection of objects. So what do we mean by well-defined? That is basically saying that if you are given an object, you should be able to determine whether or not it belongs to this collection without question. Now, it may take some thinking and even some research maybe on your part, because maybe at the very onset you don't know whether an element would belong to a set or not, but there is some decisive way to figure that out. So, for example, it says we can speak of the set of American citizens. So again, you may not know right out the gate whether someone is an American citizen or not, but there are specific conditions for being an American citizen, so you could figure it out. Like you could do the research and figure it out. On the other hand, it says we cannot speak of the set of tall people because the word tall is not precisely defined, right? That could be debatable. What is the cutoff for tall? Other people have different opinions about that. So that's what we mean by a well-defined definition for a set, is that there is a very clear way to tell whether an object is part of the set or not. I think I already used the word elements. Elements is the term for the objects in your set. And the symbol for that is like this little curvy E. When I write it, it looks kind of like that. So that is the symbol for something being an element in a set. And then there are two basic notations for sets that we use or that you will see. The first one is called set builder notation. So that is when you define a set by describing the elements. Okay, so for example here it says set A can be defined in set builder notation as A equals the set of x's such that x is a positive multiple of 5 that is less than 35. Okay, so I read that in the math speak. This vertical line, when you see that, that's read as such that. So it has described the elements. So it's all these elements x such that they are positive multiples less than 35. So I've described them to you. Now, another way to notate a list is in either roster or list notation. Sorry, you can give a set in roster or list notation. And that's when you actually list all of the elements out. So we could describe that same set A in roster notation by saying A is the set and then list all of these. So what are the positive multiples of 5 that are less than 35? 5, 10, 15, 20, 25, and 30. So that's our list or our roster notation. So there are some other important symbols that you need to know in order to answer questions about sets or to be able to decipher maybe something from one notation to the other notation. So there are all these known sets. The set of what we call natural numbers, these are also sometimes referred to as the counting numbers. That's denoted by usually a large double-barred capital N. Sometimes it is a cursive N. Sometimes you'll see something like that. These are basically the numbers 1, 2, 3, 4. Think about when you were a child and you first learned how to count. Like these are the numbers you learn: 1, 2, 3, 4, 5, and so on and so forth. So when you see these ellipses, what that tells us is that this is an infinite set. It's going to go on forever and ever, right? 1,000, a million, a billion, it just keeps going. All of those are natural numbers. You could count to them if you wanted to spend the time doing that. The set of integers is usually defined by the capital or double-barred Z. These are not only your natural numbers, so you can see 0, 1, 2, and so on and so forth is in there, but it also includes 0 and all of the negatives of these. So this is where we introduce negative numbers. Those are integers. The next set that you need to know is rational numbers. Usually this is denoted by a capital Q. These are all of the x's such that x can be expressed as p over q, where p and q are both integers and q is not equal to 0. So basically, these are any value that can be described as a fraction or expressed as a fraction. So remember, though, think back that all of your integers and all of your natural numbers above these could also be expressed as fractions, right? We could write 1 over 1 and 2 over 1 and -7 over 1. So everything that's been listed above would also be rational, but it would also then include things like 1/2 and 1/4 and 2/3 and 1/367th. You could make any fraction. Then we have the set of what we call irrational numbers. This one, the symbol varies a lot. The most common one is a capital P, but that will vary depending on where you look. These are all of the values that cannot be expressed as a fraction, basically. So anything else. So things like pi, e, these are numbers that never end. Their decimal places never end. They never repeat. They just keep going forever and ever. And these are all infinite sets because there are just, you can't, these never stop. You can always come up with some decimal that just goes on forever and never repeats. But those would all fall into the irrational numbers. And then finally, we have the set of all real numbers. So what are the real numbers? Well, that's everything basically that we've listed so far. It would be any rational or irrational number, every real number. But you will get sets probably that are described to you by saying things like x is a real number and then a description, and then you may need to write that out or you'll need to understand what those are. So just keep that in mind. Those are the symbols that you will most likely stumble upon as you're talking about and describing and writing out sets.